Module 14.1 is scatter plots and their association. Okay, many problems involving scatter plots have two parts. Part one is to make the scatter plot, okay, and the second part is to interpret it. So the first thing you got to do is look at your data. You need to label your axes, okay? So if you look, we have x being 5 through 23, okay? So we know we need to have at least 5 and go all the way to 23. They made a break in this axis. I don't think I would do that because it makes it look skewed. But if you do, look how they're counting by 1 each time, okay? It's important that you count by the same number, 5, 6, 7, 8, 9, 10. Okay, you're counting by ones. So all the data can be plotted on the x-axis. Now if you look at the y, again, they do a break and they start at 10. And the break just shows you are skipping numbers, okay? So you look right here, you have a break in the x and in the y. So they're also counting by ones on the y-axis. And then you just plot the points as ordered pairs. So like 5, 9 would be over 5 up 9, okay? And then 7, 11 would be over 7 up 11. So they're just plotting these as ordered pairs, like x and then y. Okay? So once you've made the scatter plot, then you can interpret what it means. Okay? So there are 3 things you need to know. The first one is if it has positive association. That means if you draw a line, most of those points are going upward. Okay? The second one has no or 0 association, meaning you can't really draw a line in there. It's kind of all over the place. And the last one is kind of down, okay? And this would be negative association. The second thing you can look at if it's linear or nonlinear. So this one kind of makes a line. This one isn't either. And this one curves, which makes it nonlinear, okay? So you can look for positive, 0, or negative. And sometimes you see this as no association. And then you can see if it's linear or nonlinear. Okay? So to interpret a scatter plot, data have blank if the points get higher from left to right. So they're getting higher, that'd be positive association. Data have a blank if the points go lower from left to right. That would be negative. They're going down, it's negative association. Also, the association, if it's along a line, would be linear. If the points lie along a line. The association is nonlinear if they do not lie along a line. Okay? And now when we talk about association, we start talking about what it represents. We can talk about it, maybe it's as one increases, the other increases, as one increases, the other decreases, and we'll talk about that a little bit more later. Okay, so our last part on the front page here says, data points grouped closely together is a cluster. We're just reviewing these. Okay. Data points that go up from left to right, again, is positive association. If they go down left to right, right, that's negative association. If they lie along a line, it's linear. And if they do not lie along a line, it's non-linear. Okay, so then if you turn your page to the next page of your notes, okay, we're still talking about scatter plots and their association. You're going to use the letters in these scatter plots to answer the questions. So which points or letters point to a cluster? So a group together. So here would be a cluster, right? So C would be a cluster and D would be a cluster. Okay, which letters point to positive association? So going upward, I don't see anything. These all go down. So I'm going to say none. Which letters point to negative? Well, A, B, and E and F all are negative. A, B, E, and F could all be a negative association. Which letters point to linear association? Making a line. Well, that would be A and B, right? This one makes a line. And then which letters point to nonlinear? That would be E and F. Okay, so remember, positive goes up, negative goes down. These would both be considered linear. And if it's all over the place, it's nonlinear, and it is no association. Let's go ahead and do your guided practice. So open up your workbooks. Okay, guided practice then. Make sure that you're on the correct page for 36 in your workbooks. Okay, Bob recorded his height at different ages. The table below shows his data. So the first question says to make a scatter plot of Bob's data. Remember all of these, this is like your X value and your Y, right? Age is X, height is Y, are ordered pairs. So the first pair you're going to graph is 645. So just make all of those ordered pairs. Over 6 up 45. Over 8 up to 50. Over 10 up to 55. Over 12 up to 61. Over 14, 63. Okay, now it says describe the association between Bob's age and his height and explain the association. Okay. So basically, as Bob's getting older, he's getting taller. Eventually, it's linear so far, but eventually it's going to start curving off and leveling off. So I'm going to say it's positive. And let's say basically linear. Okay. As Bob gets older, his height increases. When we talk about if it continues, it's going to level off. So, but if the data continued, Bob's height would stop increasing. Eventually, when he gets older, probably in his late teens or 20s, he's going to stop growing. Bob's height would stop increasing. Okay, question 3. The scatter plot shows the basketball shooting results for 14 players. Describe any clusters you see in the scatter plot and identify any outliers. So if we look at this graph here, there's a cluster around 20, right? Maybe, I don't know, I could even say 19 to 23. There is a cluster from 20 to 23 shots attempted. And you could have put 19 to 20, wherever you think it started. Okay. And then looks like there's a little cluster between, I don't know, 5 to 14. And then, and a small cluster from 5 to 14. Well, that's not 5. It's probably more like 7, sorry. 7 to 14. And then outlier would probably be this one. The point, let's give it an ordered pair. 35. And then about 18 is an outlier. Remember, an outlier is a piece of data that is extreme from the rest. It's far away. And then your last question says, explain how you can make a scatter plot from the set of bivariate data. Okay? So you're going to have bi means 2. So the x-axis would represent one variable. The x-axis will represent one variable, and the y-axis will represent the other variable. Then you're going to plot the points, then plot the points as ordered pairs x, y, right? For each pair of numbers in your data set.